Let us see another example of cantilever beam. We are about to draw shear force and bending moment for this cantilever beam with the combination of UDL and point loads. So let us enter into that. This is the cantilever beam that was given, and this is the point load 3 kilonewton, which is at the distance of 2 meter from the left support, only support A, and this is the UDL spread over 3 meter, and this is 5 kilonewton. So no need to calculate reactions for this because there is only support bearing all the loads. So let us find out shear force first. Shear force. So in order to calculate shear force, we are coming from right to left, right? So here let us come from right to left. So let us take the rightmost point shear force at B. So there is no force at B, that will be 0, and that 0 will be continued up to C. And C, you can see suddenly 5 kilonewton is being added. So let us see shear force at B. I repeat, shear force by definition for this is the sum of forces taken right or left to the section. So here I am considering my section. Right of the section is I have only one load, that is 5 kilonewton, and that 5 kilonewton will be continued up to D because there is no load in between C and D. And let us take at D. Shear force at D is also the same. There is no force suddenly adding at D, but that 5 kilonewton will be continued 5 kilonewton, and by the sign convention all the forces are acting downwards, and as we are coming right to left all the forces will be right downward. So right downward forces will be positive. Run. Right upward will be negative. RUN. Right upward negative. So automatically our right downward will be positive. Otherwise, think about gravitational force. It is towards the gravitational force, so it is positive. If it is the force is acting upward, that is against the gravitational force, take it as negative. Otherwise, take it as positive. And we need to calculate shear force at E. Shear force at E. So what happens to shear force at E? So we have to calculate here. My section is shifted over here, and I have to calculate the sum of all the forces acting right of the section. So 5 kilonewton is obviously there, 5 kilonewton, and here this load we need to calculate. So this is uniformly distributed load, so we have to, as it is point load, you can add directly 5 kilonewton. When it is UDL, you have to convert into point load, which is acting at the center. So this is small w multiplied by the length it is spread over, that is 2 kilonewton spread over 3 meter. So that in order to convert into the load, 2 kilonewton multiplied by the distance it is spread over, then you will get the point load. So that is the load actually. So that is 5 kilonewton plus 2 into 3 6, that is 11 kilonewton. Next shear force at F. So my section is now shifted here. I have to calculate the sum of the forces adding up to there. 5 kilonewton, 2 kilonewton per meter spreading over 3 meter, and 3. So let us add them all. 5 kilonewton plus this 2 into 3 plus 3 kilonewton. That is how much? So this is 14 kilonewton. And shear force at A. Yes, shear force at A will be the same because the shear force at E will be continued up to A because there is no load in between. So let us see, that is 14 kilonewton itself. Let us try to draw the shear force diagram now. Let us draw the shear force diagram. First we need to draw the reference line. So here we go. Okay. Now shear force at B is how much? Sorry, this is one more line you have to add. Just a minute. Okay. Okay, shear force at B is 0. So let us try to draw it now. 0, I'm marking a point here. That 0 will be continued up to C. And at C, suddenly 5 kilonewton is being added. Positive 5 kilonewton. 5 kilonewton. And up to D, it will be continued because there is no load in between. So 5 kilonewton, this is. And from D to E. So if you see at E, what we have seen, that 2 into 3 is load multiplied by the distance it is spread over. Again, that is y is equal to mx. So that is w into x. So whatever the load we are considering, capital W is w into x. This is not. This is in the form of y is equal to mx, which is the equation of straight line. That means the shear force at E is how much? 11 kilonewton. As there is UDL, so shear force is load multiplied by the distance it is spread over. It is following straight line relationship. So you have to join those 2 points with a straight line, because there is a variation of load between D and E. And if you see from C to D, there is no load variation, so that is a constant uh, line. You can draw it. Here it is a variation, you can observe, and there is no force in between E and F. So again, join them with a constant line. And at F, what happens? 3 kilonewton is being added suddenly. That will become, so at E this is for 11 kilonewton, and at F it is 14 kilonewton. So this is 14 kilonewton, and there is no load in between F and A. So that 14 kilonewton will be continued up to A, and that is positive shear force. This is all positive shear force because it is above the reference line. So to mention the points A, F, E, D, C, B. So those points will be reflected over here. So that is about shear force. So let us now draw. Let us now try to calculate bending moments. So let us calculate bending moments now. So in order to calculate bending moments, by definition, bending moment is the sum of moments right or left to this section. And when you call about a moment or bending moment, that is a force multiplied by the distance. So at B, shear force at B, there is no force. Bending moment. Bending moment at B. Bending moment at B, there is no force, and as well as there is no distance. Bending moment at B will be 0. Bending moment at C. Bending moment at C. So some of the moments we have to calculate. There is no force at B to be multiplied with distance up to C. We have the 5 kilonewton adding at C, added at C. So in order to calculate the distance, 5 multiplied by 0 up to C, right? So that is also 0. 5 into 0, let me say 0. And all the moments for cantilever will be hogging, negative bending moments. So all the loads are causing the beam to bend like this. So that is called as hogging. So if you look like this, is like crying smiley, right? So it is a trick to remember again. Hogging, a negative bending moment, it is down curve, which is considered to be a crying curve. That is a negative thinker, always cries. So the bending moment is negative over here. There is just a trick to remember, but you remember hogging and sagging. Hogging is negative bending moment, sagging is positive bending moment. Now bending moment at D. So how many forces I have here? One force multiplied by the distance up to D, that is C, the force acting at C, that is 5 into 2. And as I said, this is a hogging moment, minus 5 into 2, that is minus 10 kilonewton meter, because this is a force multiplied by distance. Now bending moment at E, let us calculate. Bending moment at E. How many forces we have up to E? From the right to left, 5 multiplied by the distance up to E. So that is minus 5 multiplied by the distance up to D, that is 2 plus 3. 2 plus 3, and another force we have, that is UDL minus 2 multiplied by the 2 is the spreaded force, that is 3 meter, that is the distance up to which it is spread. 2 into 3, and if you spread that will be at the center of gravity. So you have to calculate. So if you convert this load and it UDL into point load, that will be acting at the center of gravity, capital W, that will be okay, 2 into 3 multiplied by the distance from center of gravity up to the point E, that is nothing but 3 by 2, half of the distance, right? So that is minus 5 into 5 minus 3 into 3, because 2 will be cancelled. That is how much? Minus 34 kilonewton meter. And bending moment at F we need to calculate. So bending moment at F, again all the forces and distances up to F. So 5 multiplied by the distance up to F. So 5 into minus 5 into 2 plus 3 plus 1. 2 plus 3 plus 1 minus 2 into, again this is the load, 2 into 3 is the load multiplied by the distance up to center of gravity, that is 3 by 2 plus 1, half of the distance plus 1, 3 by 2 plus 1. So that is how much? Minus 5 into 6 minus 6 into 2.5. This is 15 minus 15 minus 30, that is minus 45 kilonewton meter. And bending moment at A. So we need to calculate all the forces multiplied by the distance up to A. So again minus 5 into 2 plus 3 plus 1 plus 2. That is how much? 2 plus 3 is 5, 6, 7, 8. 5 into 8 minus 2 into 3 is the load multiplied by the distance. So here we have to calculate the distance from center of gravity, that is 3 by 2. 1.5 plus 1 plus 2, that is 4.5. 4.5 minus 3 into 2. 3 into distance up to A. That is how much? Minus 40 minus 6 into 4.5. 27 minus 6. So that is how much? Minus 73 kilonewton. So let us now try to calculate and try to draw the bending moment diagram. So here we shall start. So bending moment at B is 0. So this is actually load into perpendicular distance. Bending moment at C is also 0. Bending moment at D, this is the load W multiplied by X. W into X, it is straight line relationship, and that is also again. Otherwise, let us put the point, all the points, and we shall join them together. Bending moment at D is how much? Minus 10 kilonewton. This is minus 10. And bending moment at E is minus 34. Bending moment F is minus 45. And this is 73. Minus 73. So this is the straight line relationship. So if you see bending moment at E, so we have seen this is a force W into X by 2. W into X into X by 2, that is WX square by 2, that is in the form of Y is equal to X square, which is the equation of parabola. Y is equal to X square, because it is WX square by 2. Whenever you get the square term, that is nothing but it is following a parabolic relationship. So whenever there is a UDL, there shall be the parabolic relationship. So join those 2 points with parabola, and again from E to F, those two are, that is a point load relationship, that is straight line relationship. Join them with the straight line. Here also join them with the straight line. Y is equal to mx relationship here. And this is also hogging bending moment, which is negative bending moment. This is shear force diagram. This is bending moment diagram. Hope it is clear to you. If you get any doubt, please let me know by the comment box. Thank you.